Despite the emergence of nuclear fuels, petroleum remains the primary energy source of both today and tomorrow. But reserves are rapidly declining and demand soaring, and nowhere in the world are new discoveries of oil more urgently needed than in Australia. 40 miles northeast of Flinders Island, in the turbulent waters of Bass Strait, an all-Australian company, NSW Oil and Gas Company NL, is drilling a promising anomaly deep below the seabed in its determined search for Australian-owned reserves of oil and gas. The well site is 64 miles southeast of the prolific Kingfish oil field and is being drilled by the 11,000-ton floating drilling vessel Glomar Conception in 282 feet of water. Access to the rig is by helicopter, with all heavy materials being brought in by workboat from the mainland. The derrick of Glomar Conception rises 170 feet above the waterline. On Sunday, October 17th, 1971, directors of NSW Oil and Gas checked on progress to date. Directors William Pettingill, Malcolm Smith and Robert Minter are welcomed aboard by senior company staff and by Chairman John Fuller. This time the well was drilling ahead at a depth of 1,700 feet. Glomar Conception epitomises man's success in mastering the challenges that confront him. With onshore oil reserves rapidly diminishing, techniques were urgently developed to permit drilling in shallow coastal waters. This success led to the remarkable achievements, now so readily accepted, whereby man has learned to discover and exploit hidden reservoirs deep below the ocean floor. The target for sailfish number 1 is a seismic anomaly interpreted as being a biothermal limestone reef, approximately 2 miles in diameter and 1,000 feet in vertical thickness. Proposed depth of the well is 6,000 feet or prior economic basement. Favourably located on the southern shelf of the Gippsland Basin, seismic surveys have detailed 23 anomalies, which will provide further exploration targets should early drilling encounter porous reef material. The link between the drilling vessel and the seabed is provided by a standpipe firmly anchored to the ocean floor and terminating inside a 30-foot square hole extending right through the keel of the drilling vessel. Ever since the driller first named it, this hole has been known as the moon pool. Throw in a coin and wish, he said. Such is the very nature of oil exploration. The collar of the standpipe is seen here, with the smaller pipe linking it to the drilling floor above, sliding neatly inside the collar as the drilling vessel surges up and down with movement of the ocean surface. The drilling bit and drill pipe are lowered within the standpipe. Movement of the vessel is accommodated by a slip joint in the drill string, which ensures rotation of the bit whilst maintaining contact with the rock being drilled at the base of the hole. Servicing of the standpipe and ancillary equipment fixed to the sea floor is provided by divers who descend in a diving bell and emerge to work on the seabed in scuba gear. Back on board, they enter a decompression chamber to prevent the bends, a condition where nitrogen bubbles form in the bloodstream from too rapid return to normal atmospheric pressure. A frolicking seal emphasises that man has entered an element foreign to him. The driller has a TV camera at the seafloor to guide him, but it seems so much easier to just have a quick look at progress on board and slip down below for a further check. wet boat Smith-Lloyd 33 comes alongside with supplies from the mainland. Two workboats are used to provide a reliable supply link with the mainland, 25 steaming hours away, and to ensure that one workboat remains nearby at all times in case of emergency. Arrival of the workboat seemed to be a sign to the waiting albatrosses and petrels that there might possibly be some tasty tidbits to collect. They are quite disillusioned about their pickings from the drilling vessel. All refuse, whether liquid or solid, is collected and containerised for disposal on shore by the workboat. Come on, surely there's something for a hungry albatross. Arrival of the workboat was an opportune time to conduct the regular lifeboat drill for off-duty personnel. Rigid safety precautions are vital to successful offshore drilling, and all personnel are thoroughly safety conscious in everything they do. Bass Strait is an exposed waterway in the roaring forties, renowned for periods of high wind and turbulent seas. Rising swell and increased ship movement produced minor problems, but drilling continued as before, again emphasising the remarkable technological achievements now showing to such advantage. Glomar Conception was designed from the keel up to utilise the most advanced techniques yet devised by the driller. Typical of the ingenious solution to major problems is the horizontal pipe rack, just forward of the drilling deck. 6,000 feet of drill pipe is extremely heavy, and whereas this could be stacked vertically when drilling on shore, it was essential to stack this pipe horizontally offshore to lower the centre of gravity of the drilling vessel and increase its stability in turbulent weather. Minor problems from increased roll of the vessel are typified by the movement on deck of spherical marker buoys used to locate the vessel above a drilling target. They will be more tightly roped together to reduce movement. Drilling proceeds despite the swell. Below the drilling deck, the roll of the vessel is clearly shown by the sway of the entry pipe leading to the standpipe, firmly anchored to the ocean floor. Movement of the Smith-Lloyd emphasises just how stable Glomar Conception really is in relation to the surface of the ocean. The drilling vessel is in fact firmly tied down to the seabed by 4 fixed anchors at bow and stern. The surge of water in the moon pool showed just how much sea movement there is, compared with the relatively small movement of the drilling vessel itself. The wear marks of the standpipe collar on the sliding entry pipe clearly shows total vertical movement of the vessel to be less than 3 feet. Drilling rate has now slowed and the drill string is pulled to change the worn drilling bit. The drill pipe is unscrewed in 90-foot lengths and lowered into the horizontal pipe rack. The ingenuity of this mechanised pipe rack is clearly shown as the 90-foot length is automatically lifted from the track and horizontally stowed in a travelling chain system until required again. Up comes another length. It is uncoupled and lowered down, down, down into the pipe rack. The extreme flexibility of the special steel used in the manufacture of drill pipe is clearly shown as these 90-foot lengths are put into temporary storage. Another one. And despite the roll of the vessel, the guides on the derrick lead the drill pipe cleanly into the pipe rack travelling mechanism. Positive action clamping tongs hold the final length of large diameter drill pipe while the drilling bit is unscrewed. The inside cutting teeth are broken and worn. A new bit is clearly required. The gauge of both old and new bits is checked to ensure that correct hole size is maintained. The new bit is coupled up and down goes the drill string once more. The sections of drill pipe immediately above the bit are very thick-walled and heavy to provide the weight on the bit required to drive it into the rock being drilled. Known as drill collars, this heavy pipe is seen stacked vertically inside the derrick frame, and further lengths are added successively until the required weight is reached. Usually 30,000 pounds or about 13.5 tons. Above the drill collars, a sliding joint accommodates the vertical movement of the vessel, while rotation is transmitted down to the bit by the rotary table on the drilling deck. Circulating fluids containing special additives are pumped down inside the drill pipe to cool and lubricate the bit, and to carry drill cuttings up the outside of the drill pipe to the surface for disposal after study by geologists who are constantly on duty during drilling. The first lighter gauge drill pipe is added to the drill string using pipe tongs aided by winch and chain to tighten the coupling. Off comes the clamp and another length of drill pipe is recovered from the mechanised horizontal pipe rack by reversing the procedures used in pulling pipe. Tongs hold the fixed pipe while the new length is screwed into the coupling. Down it goes. The slips are dropped into place to suspend all the pipe down the hole below, and another 90-foot length is lifted off the horizontal pipe rack for coupling. Up come the slips and down goes another 90 feet of pipe. Slips in again, off with the clamp, and up goes another length of pipe for coupling into the string. For the scale and weight of equipment being handled, the speed and ease of operation speaks volumes for the practical design and innovation which led to its creation. Finally, the last length of pipe is down and the swivel head is coupled to the string. And we're drilling ahead once more. Having drilled down 90 feet, the drill string is parted to add a further length of pipe. Spurting out of the uncoupled pipe is the circulating fluid used to cool and lubricate the bit and carry drill cuttings back to the surface. The drill string is lifted and lowered to flush out cuttings settled in the hole. Once again, drilling ahead. Should Lady Luck favour our endeavours, a porous reef lies ahead, containing huge reserves of petroleum to power Australia's future progress. If these hopes are realised, the standard method of completion of the hole would be the building of a platform as shown, or by the newer technique of subsea completion on the seabed, then piping the oil to a terminal ashore. Whatever the outcome at sailfish number 1, Glomar Conception will next move north to Victorian waters to drill flying fish number 1 in a new structure 10 miles west of the Barracuda gas and oil field. May Lady Luck be with her.